Hey guys, how you doing? This is Coach Scott going with a neat little trick here on Purple Wave Chemistry, and that's how to find out what the formula is if you've got the percentages. Okay, so here's the trick. If you have 25%, 50%, and 25%, what does it add up to? 100%. So if all this adds up, 23.3 to plus 30.7 plus 46.0%, we can assume that it's 100%. So we're just going to make all of these grams, right? And we're going to take it out of 100 grams, right? So if I've got magnesium, Mg, and I've got sulfur, okay, and then I also have oxygen. All right, I can assume that I have 23.3 grams of magnesium, and I've got 30.7 grams of sulfur, and 46% or 46 grams of oxygen. Okay, so number one, assume 100%, or assume 100 grams. That's what I mean, 100 grams, if it's 100%. Number two, convert grams into moles. Convert to moles. All right, so if I've got magnesium and it's at 23.3 grams, I got to convert that into moles. How do I do that? Well, I'm going to divide by the molar mass. If I have sulfur and I've got 30.7 grams of sulfur, I'm going to divide by the molar mass. And then if I have oxygen, I'm going to divide by the molar mass, 46.0 grams. I assume that it's 100 grams, so the percents are now grams. So, what is the molar mass of magnesium? Of course, I've got my handy dandy periodic table with me. So looking on the periodic table, I see that magnesium is 24.305 grams per mole. I see that sulfur is 32.065 grams per mole. And then I see that oxygen is 15.999 grams per mole. Okay, let me use my calculator real quick. So if I divide 23.3, I turn it on, 23.3, and I divide by that molar mass, 24.305, I get 0.985 or 958. 6.5, I'm going to call that 9.59 moles. All right, sulfur, if I divide it, 30.7 divided by 2.065, I get 0.957 moles. I got 46 divided by 15.999. I get 2.875 moles. Okay, so I got 0.959, 0.957, and then I got 2.875. So we can't have decimals? No. So how to convert something into a whole number? Well, I divide it by the smallest number. So if you look at 0.959, 0.957, 0.957 is smaller. If I divide 0.957 by itself, I get 1. If I take 0.959 and divide it by 0.957, I get 1.0020. I get 1, right? That's pretty dang close to 1. So that means I got 1 there and 1 there. So let's take 2.875 and divide it by, well, we got to do it by the smallest amount of moles. We get that. And that is 0.957. All right, divided by 0.957, I get 3.004. I get 3. All right, so that means that the smallest whole number ratio of this compound is MgSO3. I'm just using tricks, and that's all the empirical formula is the smallest whole number ratio. So my answer would be MgSO3. I found the formula by using a trick. Okay, so let's go down here. Let's look at this hydrate of sodium carbonate. Na2CO3 is 63% by mass water. It's a hydrate. That means it's got some water. So it's going to be something. Well, I just gave it. Oh, we don't know how many waters it is. So we've got 1 Na2CO3 times a certain number of moles of H2O. The good news is we know what the molar mass of water is. It's 18. All right. Okay. So we need to know the number of moles. So how many? Let's see. How do we get that? Oh, I know. If we subtract 63 from 100, that'll give me the mass of the Na2CO3. Minus 67, or 63. Make that what it is, 63. That means 37% of the rest of the mass is sodium carbonate, soap. Okay? So, that means I can assume that water is 63 grams because that's the percentage. We're going to call that grams now. And Na2CO3 is 37 grams. Okay? So, how would we do this? Let's get the molar mass of Na2CO3. So I'm going to do the quick way. So what I'm doing on my calculator is I am taking 2 times the molar mass of sodium, which is 22.99, and I'm adding it to 1 times 12.01, which is the molar mass of carbon, and I'm adding that to 3 times 15.99, which is the molar mass of oxygen. So give me a sec. 2 times 22.99 plus 12.01 plus 3 times 15.999. So I get a molar mass of 105.987 grams per mole. So this is going to be rough guesstimate or rough estimate. So let's do. All right. So let's convert this into moles. So that's going to be 105.987 grams per mole. And I think this will work. So that's 37 divided by 105.987. So I get 0.349 moles. I divided by the sample mass divided by the molar mass, so that should give me moles. So water, as we already figured out, is 18. So 63 divided by 18 gives me 3.5 moles. So now I'm going to divide by the smallest number of moles that we got, which is what? 0.35. 0.349 actually. So that'll give me 1 mole. And if I divide 3.5 divided by 0.349, 3.5 divided by 0.349 gives me 10.02. Or we can round a little bit. That gives me 10 moles. So that means that the formula for this would be Na2CO3 with 1 mole there and 10 moles of water. Not too shabby and not too hard. We can do this, guys. We can do this. I'm going to do one more and then call it. All right. So what is the empirical formula? The lowest whole number ratio of these elements, of these atoms, right? Different atoms that provide the properties for the compound. So what is the empirical formula of a compound that consists of 28.05% sodium, 29.26% carbon, 3.66% hydrogen, and 39.02% oxygen? Okay, I'm going to double check and make sure that all of these add up to 100 plus 29.26 plus 3.66 plus 39.02, and they do 99.9. Close enough for government work. So we can assume that all of these are now grams. The compound that weighs 100 grams. All right, so that's 28.05 grams. And the carbon is 29.26 grams. Hydrogen is 3.66 grams. And oxygen is 39.02 grams. So now I've got to convert it into moles, which means I'm going to divide by the molar mass of each one of them. I look at my periodic table. Sodium is 22.99. Grams per mole. Carbon, 12.01 grams per mole. Hydrogen, 1.0079 grams per mole. And oxygen, 15.999 grams per mole. So let's see how many moles we got. 28.05 divided by 22.99. So I get 1.22 moles. And those are moles of sodium. Carbon, 29.26, about 12.01, 2.44. Oops, I'm seeing a pattern here. 2.44 moles. Hydrogen, 3.66 divided by 1.0079, 3.63 moles. And then oxygen, 39.02 divided by 15.99, 2.44 moles. So we're going to get their least amount of moles here. I'm looking at 1.22, 2.44, 3.63, 2.44. Well, we can see that it's going to be sodium, 1.22. So I'm going to divide that by 1.22. I get 1. I divide this by 1.22. I'm going to get 2. I'm going to divide this by 1.22. I should get 3. Close anyway. And I got 2.98, so that's 3. We're rounding. 2.44 divided by 1.22. That's going to be 2. So that tells me that my empirical formula, the least whole number ratio of these components is sodium 1, carbon 2, hydrogen 3, and oxygen 2. That may not be in the right order. Talk about that. Actually, I think it's NaH3Ce2O2. But anyway, that's how we would do this. We're finding the least whole number ratio. And this is how we find experimentally. If we find out what these are and get our percentages out of the whole, we did a really good analysis. So anyway, guys, this is empirical formula. Practice this. Practice all those other ones. See how you do. You're going to do great. This is Coach Scott saying goodbye from Purple Wave Chemistry, and have a great day, and hullabaloo, knick.